Let us look at the question number 7, reverse integer. So give the integer, this integer is a 32-bit integer, and return the integer. So give 1 to 3, return 3 to 1. If give them negative 1 to 3, return the negative 3 to 1. The requirement is you only can use the 32-bit integer, so you cannot use 64-bit integer. So you cannot convert this one to the long and then calculate. So the challenge is here. Let us analyze how to solve this question and write the algorithm. So we know the 32-bit integer, the max value and the minimum value. The challenge here is if we, after convert, the converted number is less than the minimum one or bigger than the maximum one, we will return 0. The required. So actually this question is simple. If they do not ask this special requirement, so you have 1, 2, 3. So we model this value 10, we get 3, right? And 1, 2, 3 divide 10, we get 12. So we have 3. In the beginning, this one is one place. So this one will time to 10 and plus 12 model 10 again. And then this one times 10, then plus 1 model 10. So this is very easy if we have a small positive number. The only challenge is how to handle the big one. The number size is close to here. So for example, we have 3 billion something. The one place is 3. So after convert, this 3 will become the 3 billion. 3 billion is more than 2 billion, is more than the max value. So we need to find some algorithm to avoid, or we need to detect this situation. So how to do it? So remember here, every time we need to times 10 and plus the rest one, right? So the algorithm is we every time when we before the times 10, we compare the value with 2, 1, 4, 7, 4, 8, 3, 64. We divide this by 10. So we get this value. So before they add the last one, the times 10 add the last one, we compare the value. So if before times 10 is bigger than this one, so final result is must more than this one, right? And then, do we need to consider the last one? No. The reason is last one either 8 or 7, right? If we have some value is 8, even the 6 billion, is not existence in the 32-bit integer. So maximum or the minimal is 2 billion. So we don't need to care about this one. So let us write the code. So first, we need to handle the negative one. So if x less than, so if this one is 0, we return 0, and if x is negative, if x equal to integer return 0. The reason is we want to convert negative to positive, but the negative one the minimal value cannot convert to the maximum value. So we directly return this one. Otherwise, we can set some flag. This one is positive. If it's negative, so x equal to, we convert this negative to positive, and set flag to the -1. So when we return, we get a negative or positive. So first, we convert everything to the positive. Then we do x still more than 10. So the return value in the beginning equal to 0, 0 as the initialized value. So the rest will be the x model 10, right? And x will divide by 10. So, and how to handle this one? So value equal to times 10 and plus rest, right? Here we need to decide the final result is more than maximum. So here we will do the if it's more than divided 10, we return 0. So we do not want every time to calculate here. So we give the definition here is max d10. So we give the definition. Then finally we return times flag. So the tricky thing is this way. Before the times 10, we already know the final value is more than maximum, so we return 0. And then we calculate it. Okay, let us check the one. Oh, sorry about this one. It's capital X. Okay, let us submit the code to the LeetCode. Okay, yeah, code passed, and the performance is good. Thank you for watching the video.